Hello everyone, we're talking about pituitary gland, pineal gland and adrenal gland. In this section we'll talk about the pineal glands. This section has been divided into the epiphysis cerebri, which is how the development of the pineal gland starts. Then we'll talk about the development of pineal gland in detail, and finally we'll talk about the melatonin and clinical correlates. In this section we'll see how the pineal gland begins its development, completes its development, what is the function of the pineal gland, and finally what happens when the development of pineal gland goes wrong. So, pineal gland, also known as the epiphysis cerebri, it develops as a small diverticulum from the roof of the third ventricle. So, in the figure, you can see this is the region where the pineal gland lies. This red small dot and actually develops from the roof of the third ventricle. So, a pineal gland is made up of modified neuroglial cells, which are known as the pinealocytes. The pinealocytes secrete a hormone called melatonin. So, we're talking about neuroglial cells. So, neuroglial cells are actually supporting cells of the brain. So, some of the neuroglial cells in this region, they undergo differentiation to form pinealocytes. These pinealocytes are responsible for the secretion of the hormone known as melatonin. So, let's talk about the development of pineal gland. So there's a diverticulum from the roof of the third ventricle of brain. So this is the diverticulum we are talking about. Then this diverticulum undergoes enlargement. Here you can see there's enlargement in the diverticulum. Then there's the cells of the diverticulum, they proliferate to fill the lumen. Here you can see in the figure there's filling of the lumen so that the lumen is impatent at this point in time. This is the definitive pineal gland. This is the stalk of the pineal gland. This is superior lamina of the stalk and the inferior lamina of the stalk. So cells of the diverticulum, they proliferate to fill the lumen of this diverticulum. Now the diverticulum becomes a solid structure, as can be seen in the figure. Now let's see the function of melatonin, as to what melatonin does in the body. So it inhibits the secretion of gonadotrophin releasing hormone from the hypothalamus. So GnRH, which is gonadotrophin releasing hormone, it is inhibited from the hypothalamus. This inhibition, the gonadotrophin, it inhibits the gonadotrophins. The gonadotrophins are the hormones that are responsible for the secondary sexual characters in adults. So this inhibitory effect causes an effect on the reproductive system, and this is how the development of the reproductive system is delayed till a certain point of time has arrived. That is, till puberty, the delay of the development of the reproductive system is due to melatonin, which is produced by the pineal glands. Now, let's see the clinical correlates of the pineal glands. We have corpora arenacea, which is the calcified structures in the pineal gland. So here you can see in this white structure is the calcification in the pineal gland, and these are known as the corpora arenacea. These are incidental findings on CT scans. Usually you may be looking for them, you may not be looking for them, but they are sometimes present there, and you must know what corpora arenacea actually is. So moving on, we can have pinealomas. So pinealomas are actually tumors of the pineal gland. They are rare, and 50 to 70% of them are germinomas. Germinomas meaning they arise from the sequestered embryonic germ cells. So some of the embryonic germ cells, they're actually trapped in this region, and they may give rise to pinealomas. So they can compress the superior colliculus. Here you can see, as per their important location, they can actually cause compression effect on the superior colliculus and the pretactile areas of the dorsal midbrain, producing the Perinods syndrome. So the compression effect of the pinealomas, because of their size, because of their position, may give rise to Perinods syndrome. It can also cause compression of the cerebral aqueduct, and this compression of the cerebral aqueduct may lead to hydrocephalus of the non-communicating variety. So we can also have a patient with hydrocephalus, and the reason non-communicating hydrocephalus, and the reason would be reason could be a pinealoma. So this was all about this section. In this section, we talked about the development of the pineal gland. We saw the pineal gland develop from an outpouch or a diverticulum from the roof of the third ventricle itself. This diverticulum first enlarges in size, and then the cells of the diverticulum, they proliferate to form to fill up the lumen to form a solid diverticulum. This is the pineal gland. Now these cells, actually these are the neuroglial cells that are then modified to form the pinealocytes. The pinealocytes secrete a hormone which is known as the melatonin. So melatonin actually inhibits gonadotrophin releasing hormone. The gonadotrophin releasing hormone, the inhibition of gonadotrophin releasing hormone is responsible for delayed onset of or rather not delayed onset, it would be rather the timely onset of puberty when the time actually arrives. Now, we saw the clinical correlates as well. We saw what a pinealoma is and how calcification of the pineal gland presents itself on the CT scan. I hope you enjoyed this section. For further sections, keep watching sqadia.com.